Hello everybody, so in this video we will be looking at the Leetcode problem, delete the middle node of a linked list. So the problem statement says that you are given the head of the linked list, delete the middle node and return the head of the modified linked list. I have this linked list with head is given to us, and what I have to do, I have to delete the middle node. So here the middle node is, so in this example the middle node is this 7. So I have to delete this middle node and return the new linked list, which will be something like this. Now let us just look at the problem constraints. So our constraints are number of nodes are from 1 to 10 to 10 raised to power 5, and the value is also from 1 10 to power 5. So we have to do this in order and or less than complexity or less than unsquare. So what we will do, we can do it in two ways. First I'll tell you one way whose time complexity will be order of 2n, which is equal to order of n only, because we ignore the constants. So what we can do there is we will iterate through the linked list once, and we will take a variable suppose size, and we will increment the size, and at the end we will find the size. Suppose this is 1 2 3 4 5 6, so size is 7. So we will do, for odd we will do 7 by 2 plus 1, and for even we will do size by 2, and we will find that node and move to that node and delete, like we did in the previous videos. Delete at any position. You can watch the video, I'll put it in the cards, you can watch that video. So or the other method is what we can do. So other way is what we will do, we will find the middle node using two pointers by two pointers. So what is this two pointer approach? I'll just tell you. So what we will do, we will take two pointers, a slow pointer and a fast pointer, which will initially point to head. Then for until my fast is not equal to null and my fast next is not equal to null, I'll move. The slow pointer will move one step at a time, and the fast pointer will move two steps at a time. So slow moves here in the first iteration and fast goes here. So slow is here at the moment and fast is here. In the next one, slow goes here and fast goes here, and slow comes here. I'll erase the old one. Now in the next iteration, slow comes here at our middle node and our fast comes at the last, and after that our condition, while loop condition, will be false and we will come out of the loop. So at the end, the node at which our slow pointer points will be our middle node, and that is how we will get the middle node. Now the question is, we have to delete the middle node. So let me draw the above linked list again. So this is my head and this is my slow pointer as well as fast pointer. Now to delete this node, I have to break this link and I have to join this link to this node. So how I'll do that? So first of all, I'll also take a previous node which will initially point to null. Here we will do the same thing as we have done for deletion at any position in the linked list. So it will initially point to null, and when we'll enter the loop, while loop, we will first make our point our previous to our slow. So my previous, so I have entered the loop. Now my previous is here. Now previous is pointing to slow. Now my slow moves here and my fast comes here. So now in the next iteration, my previous is here. my slow is here and my fast is here. Let me just write the while loop. While fast not equal to null and fast next not equal to null. What I'll do, my previous equals to slow, slow equals to slow next, and fast equals to fast next. Okay, that is my while loop, first while loop. Now my fast is here, my slow is here. Now my previous will come here. Now for the next iteration, my fast will go here, my slow will go here, and I'll come out of the loop. Now what I'll do, I'll first of all break this link, so that is previous next, and I'll join this link here, which is slow next equals to slow next, and after that I'll point slow next to null and then delete my slow. So as this is the simple explanation for this, and this problem is medium, but I'll say if you know this concept of the middle node, this is a pretty simple problem. And before that, let me just discuss another thing, the base case. So as our number of nodes is from 1 to 10 to power 5, if there is only one node with value 1, then there will be no middle node. So if there is only one node, then there will be no middle node, and I'll just return null. So first of all, check for the base condition. If head next equals to null, I'll return null. Okay, now I'll create my nodes. One will be slow, which will point to head. One will be fast, which will also point to head. And one will be previous, which will initially point to null. Now while my fast not equal to null and fast next also not equal to null. First my previous will be pointing to slow, my slow equals to slow next, and my fast equals to fast next. Now when I'll come out of the loop, what I'll do, my previous next equals to slow next, slow next equals to null. I'll delete slow and I'll return the head. That is the code. Now I'll just run it on some sample cases. So the solution is running fine. Now let us just submit. So as you can see, the solution is submitted. So thank you for watching the video, and if you like the video, do hit the subscribe button. See you all in the next video.